Okay, so earlier today in class I recorded today's class session, but then I accidentally deleted the video. So I'm going to be making a video for today's class session here on my tablet. So this is 4.5, part 2, and today we're going to focus on solving trigonometric equations by finding a first angle and a second angle. Now, before I get started, yesterday we left off defining inverse sine, cosine, and tangent and did some examples evaluating these inverse trig functions for specific inputs. So this is just the textbook where they've defined these. So the function theta equals arcsine of y, or if the y value is given, theta, the output of arcsine of y, it's the value of theta such that y equals sine theta, and the output of arcsine always needs to be an angle between minus pi over 2 and pi over 2. That's because that was the restriction of the domain of sine to obtain an inverse. Same thing for theta equals arc cosine of x is the value of theta such that x equals cosine theta, and the angle has to be between 0 and pi. Again, that's the range of the arc cosine function, and that came from restricting the domain of cosine to 0 to pi, which then became the range of the arc cosine function. And then lastly, theta equals arc tan of m. So again, if m is given, you're trying to find the output, arc tan of m. It's going to be an angle theta such that m is equal to tangent theta. So when you plug that angle into tangent, you get m back. But you have to make sure that it's the angle between minus pi over 2 and pi over 2. And then lastly, at the bottom, the domain of arc sine and arc cosine are both the same. It's the closed interval from minus 1 to 1. And the domain of arctan is all real numbers. Make sure you look at figure 4.59 to look at the graphs. Okay, so starting with, this is where we left off yesterday, page 3 of the handout. So we already know how to find one angle for a trigonometric equation. And this is the process or method of how to find a second angle. So first of all, if we're trying to solve the equation y equals sine theta, so the y value will be given and you're trying to find the value of theta, there's going to be two solutions. So we're going to be able to find a first solution and use the first solution to find a second solution that's in the interval of 0 to 2 pi. The first solution is always going to be given by computing arc sine of the value of y. Okay, so that'll give you one angle, and that angle will be between minus pi over 2 and pi over 2. Okay, now for the second angle, so let me draw a unit circle here. Again, what we're trying to do is solve the equation y equals sine theta, and we already knew that the first angle was just given by arc sine of y, and theta 1 is going to be between minus 2 pi and 2 pi. So if I draw the unit circle and assume, let's just assume for simplicity that theta 1 is in the first quadrant, and then the y coordinate of that, okay, that's going to be the value of sine at that angle. And then the only other place where so if the angle's in the first quadrant, the only place that you'd get another angle having the same y value would have to be this angle. Let me use a different color. It'd have to be this angle in the second quadrant that has the same y value. I don't really care what the x is, but it'll be minus x over here. Okay, and then how do I get this angle right here? That's going to be my theta 2. Well, what you would do is you would rotate. It's hard for me to draw it here and not really illustrate this like I would in class, but if I start in standard position and rotate by an angle of pi and subtract the first angle, that'll give you the angle theta 2. Okay, so coming back to my handout. Okay, so again the first angle is given by arc sine of y. That'll be between minus pi over 2 and pi over 2. The second angle will be between 0 and 2 pi, and that's given by, well, you rotate pi units around and subtract the first angle, which was given by arc sine of y. Okay. Now, for the next angle, or the next part of the process, the equation x equals cosine theta, when x is not 1 or negative 1. In that case, there'd only be one angle between 0 and 2 pi. That has two solutions, theta 1 and theta 2. Theta 2 will be in 0 to 2 pi. Theta 1 is going to be given by arc cosine of x. Okay, so you apply arc cosine to the output x, and that gives you your first angle. That's a solution. And again, that'll be between 0 and pi, because that is the range of the arc cosine function. It only spits out angles between 0 and pi. Now for the second angle, let's assume again, here's my unit circle. Now here's my theta 1, where theta 1, theta sub 1 is arc cosine of y. Okay, now, sorry, that's a typo. It's arc cosine of x, because remember, cosine of an angle theta is the x coordinate up here. So that's the point xy. Okay, now which quadrant would another angle be in that has the same x coordinate? Well, that angle would have to be down here in the fourth quadrant. Okay, so this point right here will have the same x coordinate, but the y coordinate will be negative. Now, how do I arrive at this angle? Well, I can rotate all the way around 2 pi units, and then if I subtract from that 2 pi, if I subtract theta 1, I'll have another angle with the same terminal side, and therefore the same value of x. Okay, let me rephrase that one more time. So again, if I wrote, starting in standard position, if I go 2 pi units around and I subtract theta 1, I'll get another angle whose terminal side has the same x coordinate. So a second angle, so the first one's just given by arc cosine of x. The second angle can be obtained by taking 2 pi and subtracting the first angle, arc cosine of x. Okay. And like I said, theta 1 will be between 0 and pi, and the second angle will be somewhere between 0 and 2 pi. Now lastly, if you're trying to solve the equation m equals tangent theta, m will be given, and we're trying to find the angle. There's going to be two solutions, or we can find two solutions. There's actually infinitely many solutions to each of these equations. Theta 1 is just going to be applying arctangent to the value of m, so that'll give you one of the solutions to that equation. And then if you want a second solution in the interval 0 to 2 pi, well, tangent is pi periodic. Okay, so once I have my first angle, if I rotate by pi units, I'll have a new angle that has the same value of tangent. So the second angle is always just pi plus arctangent of m. Okay. So that's what we're going to be doing now. We're going to be doing examples. First, we're going to solve some basic trigonometric equations in the form y equals sine theta, x equals cosine theta, m equals tangent theta. And then we'll do some examples where we might have, a transformed sine function equal to a particular value, or a transformed cosine, or something like that. Okay, so let's go do our first example. Okay, so on the next page, example 2, part A, we're going to find two angles in 0 to 2 pi satisfying cosine of theta equals 0.6. The first observation is that 0.6 is not a special value that corresponds to one of our special angles on the unit circle. So we're going to actually have to be using our calculator for this problem. Make sure that your calculator is in radian mode. Okay, mine right now is in degree mode, so I have to hit the mode button, switch to RAD or radians. Okay, so first of all, if I want to solve cosine theta equals 0.6, a first angle or first solution is going to end up being theta 1 is equal to arc cosine of 0. Oops, I forgot a c in there. Give me a minute. It's going to be arc cosine of 0.6, or if you like, another notation is cosine inverse of 0.6, and we plug this in our calculator, and an approximation to 2 decimal places will be 0.93. Okay, so that's already going to be between 0 and 2 pi. Remember, 2 pi is approximately 6.28. So 0.93 is certainly between 0 and 2 pi. And a second angle is going to be, now for cosine, remember, you start by doing 2 pi and you subtract arc cosine of 0.6. And when I plug that in my calculator, approximated to 2 decimal places, we get our second angle, which is about 5.36 radians. Now, sometimes when you do this, your first angle might end up, well, this won't happen for cosine because the range of arc cosine is always between 0 and pi. Okay, so you shouldn't really have to worry. Your first angle will be between 0 and pi, and then the second angle will always be between 0 and 2 pi. But now, when we go and if you ever have to solve for an equation involving sine, it might be the case that your first angle is negative, right? Between negative pi over 2 and 0. In that case, you would have to add 2 pi to that angle to find another coterminal angle that has the same, that gives you the same value of sine. Okay, so let's go ahead and do part B. Okay, so now we're finding 2 angles in the interval 0 to 2 pi satisfying sine of theta equals negative 0.6. So the first angle, I'll call it theta 1. The textbook just calls it theta, but I'll just call it the first angle. That's going to be given by arc sine, or inverse sine of negative 0.6. which is approximately, using my calculator, I get a value of negative 0.64. Okay, that is certainly not in the interval from 0 to 2 pi. Okay, so we'll fix that in a second. For now, though, let's find a second solution. That's going to be given by pi minus arc sine of negative 0.6, and that'll be approximately 3.79. Okay, so ultimately this first angle, no good. It's not in the interval from 0 to 2 pi. So what I'm going to do is I'm going to adjust it a little bit. So theta 1, we're going to take our first arc sine of negative 0.6. Oops. Okay. And what we have to do now is I have to add 2 pi to that to make sure that I get another coterminal angle with the same value of sine. This is approximately 5.64. Okay, and that is also that now is a second angle. Well, technically it's my first angle between 0 and 2 pi. But when we tried it the first time, arc sine of negative 0.6 was actually less than 0, so I had to add 2 pi to that to get the angle falling in the interval 0 to 2 pi. When we went and calculated theta 2, there was no issue. Pi minus arc sine of negative 0.6, that gave us 3.79. That was already in the interval from 0 to 2 pi. Okay, now finally, last example. Find 2 angles in 0, well, last part of this example, excuse me. We're going to find 2 angles in the interval 0 to 2 pi that satisfy the equation tangent of theta equals 3. Okay, so two angles in 0 to 2 pi, this is part C of the same example, satisfying tangent of theta equals 3. So the first angle, or first solution if you will, theta 1 is going to be arctangent of positive 3, or if you like, you can also use the tan inverse notation of 3. And when I plug this in my calculator, it spits out for me 1.23 radians. Oh, not really 1.23, check for yourself, but it's really rounded to 2 decimal places, 1.25. And the next angle is always pi plus the previous one given by arctan of 3. Plug this in the calculator, and we get 4.39. Okay. Okay, so one comment before I move on to the last example, which is solving more general equations involving sine, cosine, or tangent. One is I want everybody to notice if I draw a graph of sine from 0 to 2 pi, so this is sine theta, that's our fundamental cycle. Notice that either if you're not -1 or +1, let me change colors for this part. If your output is not 1 or -1, the graph is always going to be intersected. So you draw a horizontal line at a particular height, the graph will always be intersected in 2 places, that's why we're always getting 2 solutions in the interval from 0 to 2 pi, as long as the sine theta is not 1 or -1. In that case, there's only one angle between 0 and 2 pi. The same is true for cosine. Again, if I just look at the fundamental cycle, and the graph of cosine vaguely looks like this, from 1 and -1. Again, as long as your output is not 1 or -1, any horizontal line is going to intersect cosine twice, meaning any of those solutions, or any equation x equals cosine theta will always have 2 solutions in the interval 0 to 2 pi. Okay. The same would be true of tangent. If I draw a graph of tangent now on the interval from 0 to 2 pi, now I have to be careful here, I got to break this up into fourths, that's pi over 2, that's 3 pi over 2, this is pi. Tangent has asymptotes at starting at pi over 2 plus any multiple of pi, and the graph of tangent looks like this. And I got this last piece over here. And it's the same scenario if I draw any horizontal line. Okay, between 0 and 2 pi, any horizontal line is going to intersect the graph of tangent twice. So that makes sense why we're only getting 2 solutions in the interval 0 to pi for any of these equations. Oops. Okay. So any of these equations always have 2 solutions in the interval 0 to 2 pi, unless you're in the case of sine or cosine and your y or x values plus or minus 1. Okay, so one more example where the equations are a little bit trickier. So first, example 3, part A. If you want to solve the equation 2 cosine theta minus 4 equals -3 on the interval from 0 to 2 pi, a couple things I want to point out first. Okay, now you can break this up in a step-by-step process if you like. First, what we're going to do is we're going to solve for cosine theta and reduce this problem to something that's similar to example 2. Now, if you solve for cosine theta, I won't show the steps here, but you're going to add 4 to the right and divide by 2. You'll get cosine of theta is equal to 1/2. So adding 4 to the right side gives you positive 1. Dividing by 2 solves for cosine theta, and that gives you 1/2. Okay. Now, first you're looking to get a first angle using you don't really actually have to use arc cosine here. We should be able to do this by hand. Okay, we need to find an angle between 0 and pi that gives you a cosine value of 1/2. If you look at the unit circle, that's my bad picture of a unit circle, here's the angle pi over 6. And the x-coordinate of the point here, oh, actually, I just made a mistake. So let me fix this. It's not pi over 6 that gives you a cosine value of 1/2. It's really the angle. Oof, I'm just having a bad time drawing this. So there we go. Here's my unit circle and my x and y axis. The angle pi over 3 has an x-coordinate of 1/2 and a y-coordinate of √3 over 2. Okay, so a first solution here, theta 1, is actually going to be pi over 3. And then my theta 2 is going to be obtained by taking 2 pi and subtracting pi over 3. And that ends up giving us 2 pi is 6 pi over 3 minus pi over 3. 6 pi over 3 minus pi over 3 ends up being 5 pi over 3. So there's one of the angles, and the other one was pi over 3. So there's our two angles in 0 to 2 pi that are solutions to the given equation. Okay, just one more problem that's just slightly trickier. So now if I want to solve the equation -4 sine pi over 6x minus pi over 3 plus 2 equals 4 on the interval from 0 to 12. Now, just looking at this, okay, it's not necessarily easy to know how many solutions we're going to have on that interval. But if you look at this function on the left, that's a transformation of sine where a is equal to pi over 6. So the period p, which is 2 pi divided by pi over 6, that ends up being 12. So the interval from 0 to 12 is actually one period, and we'll trace out one cycle of that graph. Okay, and just like for the functions sine, cosine, and tangent on the interval 0 to 2 pi, there will always be two solutions given by a cycle that's traced out by the period. Okay, so the period's 12. So I'll, looking at the graph of that function from 0 to 12, that would give you a full cycle, and generally you'll be able to find two solutions to this equation on that interval or cycle. Okay, so really, in a sense, this is very similar to the previous one, except for our varied input, pi over 6x minus pi thirds. First of all, we're going to isolate the sine function. Okay, so we're going to have to subtract 2 from both sides and divide by -4 on both sides. When you do that, you should obtain the equation sine pi over 6x minus pi over 3, and then taking the 4 on the right side, subtracting 2 and dividing by -4 is going to give you -1/2. Okay? And in class I did a substitution at this part, but I think for this video what I'll do is I'll just kind of highlight the input. So my varied input is pi over 6x minus pi thirds. If you think of that input just being an angle, whatever pi over 6x minus pi thirds is, we'll be able to find two solutions. So the first one, now ultimately we want to solve for x, but the pi sixth x minus pi thirds is initially going to be given by arc sine of -1/2, and you'll also have a second solution, or be able to find a second solution by taking pi over 6 x minus pi thirds and setting that equal to pi minus the arc sine of -1/2. Okay, so that's going to allow us to get two solutions. Okay. Now, arc sine of -1/2 is supposed to be the angle between -pi over 2 and pi over 2. So let me draw my unit circle. we're looking for an angle either in the first or second quadrant that has a sine value of negative 1/2. That angle has to be down here in the fourth quadrant. Now, I'm going to draw the angle in the first quadrant that has a sine or a y coordinate of 1/2. And I know that angle is pi over 6. Okay, and then think about if I, instead of rotating by the same amount in the positive direction, if you rotate by the same amount in the negative direction, that's just going to give you the negative angle minus pi over 6. Okay, so since sine of minus pi over 6 is negative 1/2, let me draw this on a new slide. Okay, so that'll give me two equations. So since arc sine of negative 1/2 is negative pi over 6, the second possibility is that pi over 6x minus pi thirds is pi minus that first angle. And then what you're going to do is you're going to solve for x on both sides. So you have pi over 6x, if you add pi over 3 to both sides, minus pi over 6 plus pi thirds is just going to give you pi over 6. Dividing both sides by pi over 6 gives you the first solution, x equals 1. That's certainly between 0 and 12. Over here, pi over 6x minus pi thirds will equal pi minus pi over 6, which is pi plus pi over 6. And you should get a 7 pi over 6. If you add pi over 3 to both sides, well, pi over 3 is 2 pi over 6 plus 7 pi, Oh, I see, I made a mistake in this previous step. It should be 7 pi over 6. Okay, I was worried there. So pi over 3 is 2 pi over 6. If I add 2 pi over 6 to the right, we're going to get 9 pi over 6. And then dividing both sides by pi over 6 is going to give you that x is equal to 9. Okay? Excuse me. So in class I did an additional example and gave it to practice for everybody. In the Chapter 4 review, there is this section that has similar type problems. Make sure you take a look at the Chapter 4 review, certainly before class tomorrow. Thank you for tuning in, and more videos will be coming, and have a good one. Bye.